Yeah, so sorry for the long hiatus. I'm gonna get back to doing these contests again and filming videos. So this video, someone gave the recommendation to have better explanations, which is my goal. So I'm gonna, after the contest, I'm going to actually think about the explanations and try to make good explanations, and then record the explanations this time. So hopefully, this time I will have better explanations for you, and that'll make the video better. So I won't so I won't worry about time, because good explanations require time, and this doesn't have to be a quick 10-minute video because it's not that kind of video. Okay, so now it's the day after the contest, and I'm going to explain my solutions to the problems. I only solved the first 3 problems this time because I haven't been doing the contest recently, so this is my first contest back from a hiatus, and therefore I got 3,599, and that's not very good, but I think it's because I got many bugs, and if I hadn't gotten so many bugs, well, I might have gotten ranked 2,000, but that's still not very good. So this time I'm going to explain the problems using more time and hopefully more clearly, because I've been given feedback that my explanations aren't very clear, and I haven't had very much time recently to do these side projects like these videos, so I'm gonna make this as clear an explanation as possible so I can cut down on the editing so that this takes less time. But that means the video is going to be longer. So hope you're okay with like a 20-minute video or something. Actually, it might be more than 20 minutes. Okay, so problem 1, destination city. You are given the array paths, where each element in paths is a 2-element array, meaning there exists a direct path going from city A to city B. Return the destination city, that is the city without any path outgoing to another city. And these cities are arranged in a line without a loop. Therefore, they're exactly one destination city. So going from city A to city B means that you can only go from A to B, and therefore you cannot go back from B to A. So my solution here was to create a map, and then the map would have the key as the source city and the value as the destination city. And there are n elements in this map if there are n pairs of cities. And for example, for this case, we have 3 elements in the array. So we would put London as a key and New York as its value. Then we would put New York as the value, and then Lima as its key. We would put New York as the key and Lima as the value, and then we would put Lima as the key and then Sao Paulo as the value. And then we would just pick any starting city to start with, because it really doesn't matter which city we start with because it's in a line anyway. So if we start in the middle, we go towards the end, and if we start at the beginning, we go towards the end anyway. So we can just pick a random city to start with, and then we follow the map. So we continue getting the value of the current city until we arrive at a city that does not have a key, because if it is the destination city, it doesn't have any city that it goes to. Therefore, it is the last city. So my code isn't here because it's the day after, and it won't show my submissions either. So wait, I wonder. Wait, I wonder if I can. Okay, here. Huh. Okay, so I guess during contests your submissions aren't counted. Yeah, I'm sorry, you can't see my code, but that's the basic idea. I hope I explained it well. If I didn't, just leave some feedback in the comments. Okay, problem 2. Check if all 1s are at least length k places away. You are given an array nums of 0s and 1s and an integer k. Return true if all 1s are at least k places away from each other, otherwise return false. Okay, so what we do here is we start with, first we check if the array is entirely zeros. If it's entirely zeros, there are no 1s at all, and therefore this condition is never checked, and therefore we return true. So that is the edge case. Otherwise, we have a pointer, that is our current value, and we iterate through 0 to n minus 1 if the array has length n. And then we also have a start pointer, which points to the location of the most recent one. So we loop through the entire array, and we check for the first instance of 1, and then we set that as the start pointer. And then we actually loop through the entire array, starting from the first value of the 1. And then when we hit a 1, we calculate the distance to the previous one using the start pointer. We subtract that and subtract by 1 to get the distance. And if it's greater than k, if it's less than k, if it's greater than k. If it's greater than k, we return false because this condition is violated. Otherwise, we set start to the current value of the position of the 1, and then we keep looping until we hit the next one. So basically, the idea is to track the location of the previous one and keep going until you hit the next one, find the distance, and then relocate. And this works because these distances are the minimum values between the ones. And if you take, for example, this one at the end and this one at the other end, that would still be greater than if there was a 1 in the middle and you took the distance there. So we don't care about that greater value because we're looking to see if there's any values less than k. And if so, we return false. Okay, problem 3. Longest continuous subarray with absolute diff less than or equal to limit. You are given an array of integers nums and an integer limit. Return the size of the longest contiguous subarray such that the absolute difference between any two elements is less than or equal to limit. And if there's no subarray, return 0. Okay, basically here we are trying to find the maximum length that a subarray can have such that the maximum minus the minimum is below the limit. Yeah, so we can pick any subarray. It doesn't have to be all subarrays with length k. It can just be any subarray with a maximum length. Basically, we use binary search here. We binary search for the length of the longest array, and I don't actually know why this works. I guess it works because, well, if it's longer than a certain value, it doesn't work, and if it's shorter than a certain value, it would work. Yeah. And we don't need to prove that. It's just kind of intuitive. And if you would like some clarification, please just ask in the comments. So we binary search on the maximum length, and to determine if the length is valid, we loop through all subarrays with length k in on time. And then to calculate the minimum and maximum values such that it satisfies the time limit, we can create a sorted array of the values that have appeared so far. So we start with the first k values, and we're binary searching on k. So we start with the first k values in the array, and then we sort them in n log n time, or k log k time. And then this is kind of like a sliding window, and then we add the next integer, and then we insert it into the array using binary search, and then we remove the first element in the array using binary search. And now we have an array that goes from index 1 to index 1 plus k. And then we go to the next integer, which is k plus 2. We add that to the array, we insert it into the sorted array using binary search, and then we remove the first element using binary search. And we can do this because the array is always sorted, and we want to maintain sorted order. And since we're always maintaining the values of this window in the sorted order, we can access the minimum and maximum of this interval or a subarray in O1 time, and therefore we can determine the range. If the range is less than or equal to limit, we know we can have an array of length k that has minimum minus maximum is less than or equal to limit, and that means the array works. And therefore, we know that value of k works. And we can return that, and then we binary search. So to analyze the time complexity of this, we know it takes log n time to find k using binary search. The sorting procedure takes k log k, or n log n, you could say. And then the insertion and deletion, we have to do that n times because we loop through the entire array once, and that's linear. So it actually takes n log n plus n log n to find if the value of k works. So that actually takes n log n. And then in total, that would take n log n times log n, which is n log squared n. And that satisfies the constraint because 10 to the 5 has a log value of approximately like 20 or something. Actually, it's around 16. Yeah, so the log value of 10 to the 5 is approximately 16. And then 16 squared is about 200. And then we have 200 times n, which is 10 to the 5, and that takes us to 10 to the 7 times 2. And then adding on some other coefficients gets us about to 10 to the 8, and that's the limit. So yeah, that's how you solve the problem. And I haven't solved problem 4. I will probably actually take a look later. It doesn't look like it'd be that difficult, but yeah, I'll take a look at it later. I'm sorry, I probably should have taken a look now, but yeah, I hope the explanations were good, and if you think I could improve on them, please let me know in the comments, and in the future I'll have more time to do these projects once school ends, and that'll be around June, the end of June. And I'll do the use of code video then, or if I have time earlier, I'll do it earlier. So yeah, hopefully this video will not be too long and rambly, but it probably will be, because I'm not going to edit it that much. And yeah, sorry for the long hiatus, and I hope you enjoyed this video. Leave any feedback in the comments below, and I'll see you next week, hopefully. Goodbye.